Welcome back to EduTube's Advanced Blockchain series. I'm really glad to see you here again. By now, you've already explored the layers of blockchain. Layer 0, the base layer that connects different blockchains. Layer 1, the main blockchain platforms like Bitcoin and Ethereum. And Layer 2, the technology that helps speed things up without compromising security. Today, we'll build on that foundation by exploring an important design concept in blockchain technology, modular versus monolithic blockchain design. Understanding this difference will help you grasp why some blockchains are better suited for scalability, innovation, and real-world applications. Introducing the topic, with an analogy to start, imagine two very different places. The first is a small workshop where one person does everything: designing, building, marketing, and selling. It's simple and self-contained. The second is a large shopping mall, where different shops specialize in shoes, food, clothes, electronics, and more. Each shop focuses on its own area, but together they create a vibrant and flexible shopping experience. Monolithic blockchains are like the single workshop, all functions in one place. Modular blockchains are like the shopping mall, specialized and separated but working together smoothly. What is a monolithic blockchain? A monolithic blockchain is a system where all the core functions are handled by one single layer. This means the blockchain processes transactions, runs smart contracts, reaches consensus on the state of the network, and stores data, all within the same network layer. Examples of monolithic blockchains include Bitcoin and early versions of Ethereum. These blockchains do everything themselves. The advantages of this approach are clear: simplicity and strong security. Since all tasks happen in one place, it's easier to ensure everything works as expected and keep the network secure. Developers also find it easier to start building applications because the system is straightforward. However, there are important drawbacks. Monolithic blockchains face serious scalability limits. They can only process a limited number of transactions per second. Upgrading or improving one function often affects the entire system, making changes slower and riskier. It's like a small kitchen where one chef does everything. When many customers arrive, delays are inevitable. What is a modular blockchain? On the other hand, a modular blockchain breaks down the blockchain functions into separate layers, each focusing on a specific task. One layer might handle transaction execution, another layer manages consensus, ensuring all nodes agree, and a third ensures data is available and stored properly. This separation allows each layer to specialize and optimize independently. Examples of modular blockchain projects include Celestia, which focuses on consensus and data availability, Cosmos, which enables many independent blockchains to connect, and the modern Ethereum ecosystem, where Layer 1 handles consensus and data, while Layer 2 solutions like Optimism and Arbitrum take care of execution. The modular design offers many benefits. It's much more scalable, as each layer can improve without slowing down the others. Developers get more flexibility to customize layers for their needs. Upgrades become easier and safer because changes in one layer don't break the whole system. The trade-off? Modular blockchains are more complex to design and require coordination between layers. This design is still evolving, but it's opening up exciting possibilities. Imagine a movie production. Writers write the script, directors direct, editors edit, and distributors distribute. Each team focuses on their job, but together they create a great film. Comparing monolithic and modular designs. So, how do monolithic and modular blockchains differ in practice? Structure. Monolithic blockchains bundle all functions together, while modular blockchains separate these into specialized layers. Scalability. Monolithic blockchains have limited capacity to grow, whereas modular blockchains can scale better by optimizing individual layers. Security. Monolithic blockchains offer strong security through tight integration. Modular blockchains also provide strong security but add flexibility to upgrade parts independently. Upgradability. Monolithic chains are harder to upgrade due to their intertwined nature. Modular chains make upgrades safer and quicker by isolating changes. Developer usability. Monolithic blockchains are simpler for developers to begin with, but modular blockchains offer more tools and customization as projects. Why modular blockchains are gaining popularity? The modular design is gaining momentum because it solves real problems. It allows blockchains to customize according to different use cases. For example, a gaming application might prioritize fast execution, while a financial system might focus on security. Scale efficiently without compromising on decentralization or security. Encourage innovation by enabling developers to build or improve specific layers independently. Create interconnected ecosystems where different blockchains share responsibilities and work seamlessly. Think of it like upgrading from a simple flip phone to a smartphone packed with apps. Each app has its unique function, making the device much more powerful and flexible. What should businesses, developers, and consultants keep in mind? If you're advising a business or developing a blockchain project, consider these questions. What are your priorities? Speed, security, decentralization, or flexibility? What experience do your users expect? Fast transactions, low fees, or specific features? How much do you expect the project to grow? Modular designs support easy scaling. Do you want your blockchain to be part of a larger ecosystem or operate independently? Remember, modular designs aren't always the best fit, but they provide exciting options that weren't possible before. A story to illustrate. Imagine a small town with one hospital, one school, and one store, all working fine when the population is small. But as the town grows, the hospital gets crowded, the school overflows, and the store runs out of goods. To fix this, the town plans a new city design. Different areas for hospitals, schools, shopping, connected by wide roads. This design supports millions of people comfortably. That's the shift from monolithic to modular blockchains, moving from one crowded workshop to a well-organized mall or city. Summary and key takeaways to wrap up. Monolithic blockchains do everything in one layer. They are simple but face limits in scalability and flexibility. Modular blockchains split core functions into layers, enabling greater scalability, flexibility, and faster innovation. Modular design represents the future of blockchain technology. Collaborative, optimized, and ready for real-world challenges. Understanding this difference is essential whether you are a learner, developer, consultant, or business leader in blockchain. Preview of next lecture. In our next lecture, we will explore scalability solutions, diving deeper into sharding, rollups, and sidechains. You'll learn how these solutions boost blockchain performance and why they matter for the future. If you haven't subscribed to EduTube yet, now is the perfect time to join our growing community of blockchain learners. Please like this video, share your thoughts in the comments, and share it with friends who want to learn blockchain the easy way. Remember, the future belongs to those who understand how to build.
EduTube, your gateway to blockchain wisdom.